Hi. Today we're going to talk a little bit about pedigree charts. I'd like to start with a definition. A pedigree chart shows the following and passing of a trait from generation to generation. It looks kind of like a family tree. And when I go through the parts and show you how it works, you'll see what I mean. Most of you are familiar with family trees, and you'll see how a pedigree looks the same, but in reality it isn't the same thing because it's actually tracking a genetic trait rather than just showing who your parents and your grandparents are. The square usually represents a male. The circle usually represents a female. The shaded shape, meaning the shading in of the male or the female shape, represents the recessive trait being expressed. Now remember, the recessive trait is like little t, little t. That's the only way you can get the recessive trait. Or little r, little r. So if it's shaded in, such as these two are, the recessive trait means that you're going to have both lowercase letters, or homozygous recessive. Carriers have only one gene, which means it's either a big T, little t, or in the case of R, it's a big R, little r. Those don't express the trait being the recessive trait. Remember, that's what they track. They track recessive traits. So if it's not shaded in, it's not showing the recessive trait. Sometimes they express carriers, or hybrids as they call them, as a half-shaded shape, as you can see down here in the bottom. A half-shaded shape sometimes shows a carrier. But in most of our examples, you won't see that because in the examples we're going to be doing in class, your job is to find out which ones are the carriers. So I wouldn't want to show them to you. It'd be too easy to do. All right, let's go on to the next slide. The line between a square and a circle, as you can see, both of these are not shaded, so they don't show the recessive trait. They may indeed have one, but they're not showing it. Okay, that signifies a marriage. If you have the line between the two, such as here, and a line coming down to a group of individuals that come off of there, those would be children. So these are the children down in here, this group. Okay? This is called generation 1 up in here. This is their parents. This is called generation 2 down in this area. These are the offspring, or children. Now, how you put them on the list varies a little bit. Most of the time, children go from oldest to youngest, left to right. So this child here would be the eldest child, and this child here would be the youngest child. Now notice, do you see how this one right here is shaded in? So they show the recessive trait, while all 4 of the other ones do not. Okay? So you can start to see how a pedigree isn't like a family tree. It not only shows you who is who, but it also shows you what traits are carried. If you want to know how many generations there are, you count the rows. This is a row, and this is a row. So there's 1, 2. Therefore, there are 2 generations. Okay, let's go on to the next slide. In this slide, I give you an example. I number each of the individuals so you can tell how many, or what individual you're talking about when you're answering the questions. For example, one of the questions I may ask, how many males? And it's simple to do. You count them. This is 1, this is 2, this is 3, this is 4, and this is 5. So there are 5 males. I may ask the question, how many females? Very normal questions to ask in a pedigree quiz. Well, this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Remember, you don't have to have the same number of each. So there are 6 females. Now I'll ask the question, how many generations? Now I want you to figure that one out without me saying anything. I'll give you a minute to do that. Okay, if you don't have it yet, pause the tape and then come back to it when you're ready. This would be one generation. This would be a second generation. This would be a third generation. And do you see it? This is the fourth generation. So horizontal lines of characters. There's one, there's the second one, there's the third one, and there's the fourth one. Wherever you have a horizontal line of individuals, that is a new generation. So there's 1, 2, 3, 4 generations here. Okay? How many marriages? Well, count them up. How many do you see? I see one here, and a marriage looks like a T. I see one here, and I also see one down here at the bottom. Now, is this a marriage here? Is it? No. That's just showing these are two siblings. This is a brother and a sister. Okay? So if you count the marriages, you have 1, 2, 3 marriages. Okay. Now, you have to have a key for one of these. The key for this one is going to be normal skin dominant over albino skin. Okay? So the normal skin is going to be signified by a capital N, being that it's dominant, and N for normal. So the normal skin color, which is your normal skin color, whether it be, black, white, yellow, whatever skin you have, that's going to be normal. Albino skin has no pigment in it, and it's very, very light colored. I mean, so light that you can easily tell it even on a person that's Caucasian. So we're going to signify that by the lowercase n, little n, and it's recessive. Now, when you look on this chart of this pedigree here, you should be able to tell a couple of things really simply. First of all, you should look at number 6, number 8, number 10, and number 11, and be able to identify something about each one of those immediately. The first thing you should be able to identify is that 6, 8, 10, and 11 are all recessive because they're colored in. So we can label them little n, for each one of those. There. Now you have all the recessives filled in. Okay. Now I want to go talk about the rules. The rest of the pedigree is all blank. Number 1, 2, 3, 4, 5, 7, and 9 are not filled in. You can't easily tell what they are because although they show the dominant trait, you don't know if they're showing a hybrid or if it's actually pure dominant. So you have to apply some rules, and these rules will very easily tell you which is which. Let me go show you the rules, and then we'll come back. I want you to write these down. Pause the tape and write them down. Rule number 1. All dominant children of a pure recessive parent are hybrid. Okay? Rule number 2. All dominant parents of a pure recessive child are hybrid. Now it may sound confusing, but when you look at the pedigree chart, you can apply this rule and it works very well. And rule number 3, you can never prove pure dominant. Okay? Make sure you've written them down. Pause the tape if you have to, and then we'll go back. Now, let's look at number 7. If you look at number 7, you can tell it's dominant because it's not shaded in. But if you look at number 11 here, you'll notice it's a pure recessive child. Well, one of the second rules says that all dominant parents of a pure recessive child are hybrid. So that must mean that 7 is hybrid. So you can fill it in as big N, little n. Now if you come over here to number 10 and you look at number 10, you can see that number 10 is pure recessive. Now remember, number 8 isn't in this family. There's no line here. So you really can't say anything about number 8. So you can't include him when figuring out people in this pedigree. Only people below this, below number 8 in the pedigree. This is a married in person. You can't actually talk about their parents in this pedigree. So this doesn't exist in here. Number 10 is pure recessive. So that must mean that the parents, according to Rule 2, all dominant parents of a pure recessive child are hybrid. There are the two dominant parents of that pure recessive child. So they must be hybrid. So you can fill them in. If we continue on, you look at number 6. 6 is pure recessive. And it is a child of two dominant parents. So you know by rule number 2, the two dominant parents have to be hybrids. So is that everybody on the chart you can figure out? Because if you apply rule number 1, well, nobody on this chart has any pure recessive children that are unidentified. And rule number 2 we just did. And rule number 3 very clearly states you cannot have any pure dominance. So anything left over, number 3 for example, and number 9, have to be filled in with big N line. The line signifies that you don't know if it's a big N or a little n. You can't tell one way or the other. So you just have to put a line instead. Okay?